So right now we want to switch over to our first presentation this evening. We're going to turn it over to Gary Varney and Brian Day, who are going to talk to us about imaging the moon. Remember, if you have a question for them, it's #AskNASA.
Hello again, everyone. This is Gary, and welcome to the 2020 International Observe the Moon event. From my location here in Southeast Florida, the moon has not risen yet, so I've got about another hour and 20 minutes to go before moonrise. So what I'm showing you now on the screen is from a lunar globe application that I have, and this is the 71% waxing phase that will appear in the sky in the coming hours once we reach moonrise. So a little bit about me briefly. I've always been drawn to the night sky. My brothers had a basic vintage refractor telescope, very similar to the one seen here in this photo, when I was young. And after many a terrestrial view living in the rolling hills of northern West Virginia, I eventually turned that telescope towards the moon, and that was the game-changing epiphany moment for me, I believe. That, and along with growing up during the heady days of the space program, my fascination and eventual passion has been the night sky, and especially the bright and ever-changing surface of the moon. My high school fortunately had a planetarium with a Spitz A3P projector in it, seen here in these pictures. And obviously two of my favorite classes during that time were astronomy and space science. And having hands-on time at the controls of this planetarium was quite a memorable experience. And again, very, very fortunate to have such an opportunity. So there are several ways that you can enjoy observing the moon. As seen here in this photo, which I took a few years back, this was from Hollywood Beach, Florida, and this was moonrise during an eclipse, which was quite an interesting treat visually. But naked eye observations are one of the easiest ways to enjoy the moon. Get outside, look up, find the moon. But especially when it's close to the horizon, rising or setting, and it takes on that reddish hue due to how the atmosphere bends light. It can be very, very picturesque. And it also appears, when it's close to the horizon, it appears to be larger than when you see it high overhead. But don't let that fool you. That's the moon illusion, and that's basically a trick of your imagination. And it has a lot to do with how the brain perceives distances. The moon is actually the same size at the horizon as it is when it is high above. And that's about roughly the size of your thumbnail when held at arm's length. So you can test that theory. You can take a photo of the moon when it's close to the horizon after it has just risen. Wait about 5 or 6 hours. When it's directly overhead, take another picture, put them side by side, and you will see that they are the same size in diameter. But even behind varying levels of thin clouds, gazing at the moon can still be quite mesmerizing. Another way would be to grab yourself a pair of binoculars and look up. A basic pair of binoculars are going to provide a very nice and slightly magnified view of the moon. About 7 to 10% or 10 times magnification, if memory serves, would be from just your basic, very affordable set of binoculars. But one nice thing about binocular viewing is you're providing a different image to each eye, and it takes on a 3D effect. So when you're looking at the moon, you see it as a sphere, floating in space, as opposed to just looking at a monocular with one eye, and you see it as a round, flat disc. And you can get more powerful binoculars if you want more magnification, but the more you magnify, the more you need to stabilize yourself, like lean up against a tree or a building, or get a tripod, as seen here with this photo. And there's even some high-end binoculars that have a self-stabilizing feature that you can toggle off and on, but that starts to get a little pricey, but the right tool for the job. So also, lastly, using a telescope. There are you can also look for used equipment. A lot of people will sell off their previous purchases as they advance through their experience and upgrade to more higher power or different types of equipment. So there's some good affordable deals out there that you could find. And about 13 years ago, that's kind of what I did. I decided it was time to get myself a decent and powerful novice telescope that was something all around good performance. So I invested in this 8-inch Newtonian reflector seen here in this picture. Now this particular scope here is a push tube. What that means is simply that you must push it to the right altitude and azimuth to find your target in the sky. And when you look through the eyepiece, you'll see that the field of view is constantly in motion. That is due to Earth's rotation. So to cope with that, I built myself a dual-axis cylindrical bearing equatorial platform, which you can see here underneath the telescope, that little rectangular box. And what that did was provide a stable field of view for upwards of an hour. And after spending many hours gazing into the night sky through the eyepiece, looking at some easily spottable deep space objects, looking at the planets, looking at the moon, I wanted to be able to share these amazing views with other people. So I then got myself a little $99 planetary camera, and the learning curve went up, and I began my journey into the world of astrophotography. Now another easier way to do astrophotography is using your smartphone. You can acquire some pretty impressive photos of the moon using your smartphone. It takes a little practice, a little patience. For some it takes a lot of patience, but you have to get the camera right at that sweet spot over the eyepiece, much like when you look through with your eye. You have to move around a little bit, right, until your eye is right in the perfect, right in that focal point. You have to do the same with the camera. And to make this easier, you can get a universal smartphone adapter. What these do is they hold on to the eyepiece, they hold on to your phone. They are adjustable to allow you to move the phone until you get the lens of the camera right in that sweet spot over the eyepiece, and it holds it there firmly. So now all you have to do is slew the scope. When you see your target, or if you're zoomed in, you see the crater that maybe you want to look at on the moon is in your field of view. All you have to do is touch the screen and click. You are an astrophotographer. Some of these images here I'm showing you now were taken through that fashion with an iPhone 6 through this 8-inch telescope through a 20mm eyepiece. This image here is taken during an eclipse. This was back in early 2019, I believe, during the Blood Wolf eclipse. This was for an online collaboration with my friend from Italy, Gianluca Massi. This was an online event for the Virtual Telescope Project. This image here is a series of smartphone images put together in a composite image. This was also for another online event for the Virtual Telescope Project. And And that last image that you see, the moon is orange, that's not due to the penumbral effect of the eclipse. That's because it was about to dip below the horizon, and that's due to the atmospheric bending of light. But you can see across the series of images how the moon is slowly moving into Earth's shadow, which is pretty cool. But single frame exposures are at the mercy of the stability of the atmosphere, also at the operation of the imaging sensor, especially at higher magnifications. And if you look at any digital photograph and you zoom in on it, you will notice that it doesn't take long before the image is going to start to distort, and that the noise in the image becomes more apparent. So to get higher clarity, higher quality images, what you need to do is take hundreds, if not thousands, of sequential images in rapid succession, and you combine them through the process which is called stacking. So what do you mean by noise in a photograph? Well, any digital imaging sensor is a series of pixels that are together in an array, and they are designed to capture light. Well, what is light? Light is particles, photons. So the main source for noise in a single planetary image is going to be due to the particle nature of light. Photons arrive at random intervals, which means that the number of photons captured by any individual pixel during a single capture is going to fluctuate. And with all the image pixels in the array randomly fluctuating in this manner, that's where the noise comes from. And by calculation, I think it's roughly about 10% of the pixels in any single frame image are going to be noise. So the way you improve on this signal to noise ratio in the individual frames is, well, there are several ways you can do it. You can use a more efficient chip. You can increase the photon count per pixel. To accomplish this, there's different things you can do. You can use a larger scope, larger aperture scope, which will let in more light. Or you can increase the exposure time and lower the gain, which is going to increase your signal, and it's going to lower the noise by lowering the gain. But this now leaves you subject to possibly atmospheric effects, and get smears in your image. You can use a camera that has larger pixels, or you can image at a shorter effective focal length, but both of these will spread light over fewer pixels, which now can reduce your resolution. So if you use significantly shorter exposure, you get less smearing due to atmospheric movement, but you now need to raise your gain to compensate to keep your histogram at a particular level, which adds noise. But stacking improves this signal to noise ratio, and it copes with fluctuations in the atmosphere as well. These fluctuations are what people refer to as seeing conditions, and that refers to the stability and the clarity of the atmosphere. So what do you mean by seeing conditions? Okay, well, think of a shallow pool of water, as seen here in this photo, and you toss a coin into the bottom of the pool. Now when the water is flat and calm and the water is clear, not only can you see that, hey, there's a coin at the bottom of the pool, but you can also tell that that's a quarter and that is facing tails up. This would be excellent seeing and excellent transparency. Now if the breeze picks up a little bit, you begin to get a series of ripples and disturbances across the surface of the water, but you can still see the coin. Now if you are capturing images in rapid succession, some of the images are going to be in between the ripples, where the surface is not subject to any distortion. Now what you would do is through the stacking process, you throw away all those images that are distorted and bent, and you only keep the ones that are in between the ripples that are clear. That's part of what the stacking process will do. Now if you really splash around in the water, and the disturbance would be so severe, you can't really see the target, and that would be bad seeing. Now as far as transparency goes, You throw some dirt or something into the water to cloud it up a little bit, and this would be lesser transparency. You throw in more and more dirt, and the transparency gets worse and worse and worse. Eventually the skies or the water becomes so cloudy the transparency is zero. The atmosphere has a very similar behavior. So hopefully that explains the seeing conditions. Okay, so you don't want to use a smartphone to take images of the moon. That's fine. There are other ways to acquire images. Some like to use DSLR cameras that have been adapted, and they have connectors that mate it to the telescope. But these types of cameras excel at deep space objects. But for planetary, personally I prefer using a planetary imaging camera. And they're designed more for this purpose, and they provide better results. Planetary cameras insert into the scope in place of the eyepiece, which makes it easy, and then you just connect it to your PC via a USB connection. But you need software that allows you to operate the camera, and most, if not all, come with some sort of software for this purpose, or they direct you to some site where you download free software online. And there are a few flavors of this software out there, such as SharpCap, EasyCap, but my personal software of choice is FireCapture. It then became apparent to me that I needed a better camera, and I needed a different style and more powerful type of telescope that would better suit my needs. And I've since acquired two Schmidt-Cassegrain telescopes, which provide higher magnification and stable tracking. You can see them here in this photo. I've also added various types of planetary cameras from several different manufacturers. Monochrome cameras with filter wheels, color cameras that utilize an atmospheric dispersion corrector, or ADC for short. Many of you have probably heard of ADC and you wonder what that is. Well, what this appliance does is it corrects the prismatic smearing effect of the atmosphere. The lower in altitude a target is, the more atmosphere that you're looking through, and that the prism effect is greater. So, for instance, when a planet is, say, 30 degrees above the horizon, you're looking through twice the amount of atmosphere as you would compared to looking at something when it's directly overhead. What the ADC does through a pair of internal prisms is that it bends the light rays back and reduces the distortion, but they require tuning to the particular altitude in which your target is. So there is a feature within FireCapture that is a tool that assists you in this tuning process, but I only use the ADC when doing color imaging of the planets. For the moon, I prefer to use my Altair Hypercam IMX174, which is a mono camera, and a green filter. As you can see here in this photo, this is the orientation into the visual back of the telescope. There's also a Barlow in there, 2x Barlow. If seeing is really good, I swap that out and I use a 3x Barlow. But I found that using the green filter results in less of a ghosting effect within the dark craters on the lunar surface. Alright, so enough of the technicals. I've either melted your brain or bored you to tears. So what I'd like to do now is take a few minutes and share with you a video that I made recently of some of my lunar images that I've captured from my home observatory here in South Florida. And it is accompanied by some very befitting music from Jamie Dupuis. And during Apollo 11, when Buzz Aldrin stood on the LEM waiting to take his first steps on the surface, take images of the moon. You can see here on the screen there is a photo of one of my setups here. This is this purple device is an Altair IMX 174 Hypercam monochrome camera. This is a manual 5-position filter wheel. This is an Excel 2.0 Barlow lens, which effectively doubles the focal length of the telescope. And that is all placed here into the visual back of the telescope, which is a Celestron CPC Deluxe 1100 HD, which is an 11-inch Schmidt Cassegrain telescope. So imaging is much like an art form. Two people can capture the same target using similar or exactly the same telescope hardware and get two different results, much like a painter or two painters could look at the same vista and come up with two different works of art on the canvas. So there is really no one set way of doing this. So what I'm going to show you very briefly, due to time constraints, is how I go through and process and capture images. So the software that I use for the stacking process is AutoStackered. When you click open, you point it to your capture file. In this case, this image from September 5th was taken during very good seeing. And what you're looking at here is the first frame in the capture. You can see there is actually a fair amount of detail in the image, in the raw frame, and some noise in here, which is to be expected. And this little slider up here, if you scrub through it, you can see as you go through the frames that there was a little bit of drift, so the image is jumping around a little bit. But you can see here that I had a total of 3,433 frames in this capture. So what the stacking software is going to do is go through and look at each individual frame and classify it in order of what it believes is its level of quality. So what I need to do is here on this radio button, make sure it's clicked on surface. If I was doing planetary, you would click this, which uses center of gravity. Surface would be for lunar or solar images, which basically eats up your entire field of view for the most part. Since I've had some drift in here, I'm going to click this improve tracking, which will help with a little bit of drift in the image, but it will make it take a little bit longer. I will leave this expand button clicked, and I'll show you later what this does. The quality estimator here, since this was relatively good seeing, I'm going to set it at 5. If you have noisier data, you want to raise this up. You can go higher. But if you don't set this correctly, it can be fooled by noise. And I'm going to go ahead and click Analyze. And what it's going to do is take some time, go through and look at all those frames and rearrange them in order of best quality to worst quality, and that will be reflected in a graph here that will appear on the screen. So I will pause and we'll come back to that once this process completes, because that's probably going to take upwards of about 20 minutes. Alright, so now you notice that we've traveled 1,655 seconds into the future. And that's about, what, 26 minutes, 27 minutes? The analysis phase is completed. And now this red box that it is drawn here, let me change the zoom, lower this down a little bit so you can see the entire field of view. Remember earlier I mentioned the expand and cropped here. If I would have selected cropped, it basically would have deleted everything outside of this red box. By expand, it leaves it and it lets me crop it. Maybe you might have enough quality outside of this area here that you want to keep. So I'd like to decide that instead of the software, that's all. So now the next thing to do is you want to place alignment points. For lunar, I like to use the 200 size. I'll click once and you can get an idea of the area that encompasses. You could increase that by clicking these arrows and go a little higher. If you right click it, it removes them. So I'm going to let the software place the alignment points, but this minimum brightness setting here, if I left this at 10, the alignment points would stop somewhere around this area where the cursor is going and leave out these darker areas that are right up against the terminator. So I want those to be in the sharpened field of view, as that's some of the most impressive features on the surface. If I did it to 0, it places them even out here in the dark space where you really don't want them. So, and I also like to click multi-scale, and you'll see what that does. But it's going to go ahead and decide where to place these alignment points. It takes a few moments. And what the multi-scale will do is it then will go something larger, maybe half to twice as much as you've selected here, and see where it can place alignment points that it determines might also be beneficial in the final quality of the image. That's the way I understand it. And you can see one of them here now. This light blue square is much larger than the 200, so that's part of this multi-scale process. And now you can see that it's done. It even placed a larger alignment point here that it selected. Now notice up here, because of the darkness, I'm going to go ahead and manually place one. To do that, I'm going to follow the same alignment that it's using here on the previously placed points, and just click one in there, and it should add that point for me. If it'll let me. Alright, so the stacking is completed. You can see here that it did take a little bit of time, and if I do clear on these alignment points, you can see the final stacked image here. So now what I'm going to do is send this over into another piece of software for the sharpening, and that's called Registax. So I open Registax and I go ahead and load this file that we just stacked. And there you can see that is the result of stacking 50% of the frames, which comes out to be what, about 1,721 frames combined to make this image. So now we're going to do a little bit of sharpening. Just to go over here at the top here in Registax, you have this show full image, which will back out and show you the full field of view that you've captured. And if you unclick that, it brings it up to 100% zoom. So and then you can use these little sliders to move around. Now on the left here, these are called wavelets. So typically what I'm going to do is I'm going to go ahead and push wavelet 1 up to about 50%, and you notice that it has now sharpened this little area of the field of view. Let me go half that again to about 75 or so, and I can observe to what it is doing to the image. Push it all the way to 100 and see what happens. What you want to do is kind of make sure that you don't over sharpen an image. So if you do it in incremental steps like that, you get an idea of what you got in your data. So the better your data, the better you can sharpen it. Less frames, the sharpening, you'd be adding noise a lot more frequently. So I mean, you can see now, look how many more smaller impacts are now visible within Janssen that were not there before. If I turn the layer off, you can see the difference. Now layer 2, let's go ahead and apply the same logic. Let's go about halfway. Now it's starting to get a little, almost a little rough, a little rugged. And just to prove it, I'll go higher. And if you overcook, over sharpen an image, and I'll go ahead and push all these sliders up, you can see how it starts to really distort and burn almost. And you can really ruin a good capture by over sharpening. I mean, that to my eye looks as though that's a cake that's been over baked, something that's been over fried, whatever you want to call it. I'm just going to reset the wavelets. One good rule of thumb to keep in mind when sharpening too is that less is more. So you saw what I did with about 100% on level 1. I'm going to just go ahead and go maybe to about 40 on level 2, and then we'll do a little bit on level 3. But again, what you can do is check, turn these little, toggle these little check marks off and on, and watch the field of view here. As I turn it off, I just removed the level 3 sharpening, turn it back on, reapply it. Maybe just bump a little bit up here on the bottom. To me, that looks good. I could probably go spend a little bit more time, and you can. This sharpen value here, if you click this up arrow, what it does is it's going to increase what layer 1 does. Now you can see we've definitely added some more sharpening. I'll turn it down. Notice how it subsided a little bit. You could play with those as well. But I'm just, for the sake of time, I'm going to go ahead and leave it here. Come up here and click Do All, and it is going to sharpen the entire field of view. You can also come over here if you want and adjust your contrast settings, your brightness settings. You can come up here and toggle things on, like the histogram if you want to look at that. Your gamma settings you can change. I do all of these in the next step in Photoshop, so that's why I'm not really going over these. If this were a color image, you can do an RGB align here. Registacks also can stack images. I like how AutoStacker performs much better than I do Registack, so I just use it for the wavelet sharpening feature that I just shown you here. So I'm going to go ahead and click Full Image. Now you notice the edge up here, how it's a little skewed. That's where the frames and the field of view is drifting around a little bit. This will get cropped off within the next step. So go ahead and save the image, and then we will proceed with the next phase, which is Photoshop. Last piece that I do is in Photoshop. So first thing I'm going to do is go to Image, Adjustments, Levels, and we bring up the histogram a little bit to where it's not overexposed. Then we check this slider here, raise it up to introduce some intensity in the image, and then go to this first slider and reduce it a few clicks to remove some of that unwanted noise here in the dark area. Push this back to 100%. And say OK. Now we come to the cropping tool, and we're going to crop out some of the unwanted data here that was not stacked quite well, as you can see in this edge here. That's due to the drift in the image. AutoStacker could have cropped it for me, but I like to do it myself. So I'm just going to go around to the edge of the image here and just crop out that unwanted data. Right click, say crop, and then the next thing would be to go to the camera raw filter and just do some cosmetic tweaks. First thing that I do is go to the texture and slide it a little bit and enhance the contrast of the texture features a little bit to bring out some of the surface details. Do the same with clarity. Don't want to push it too high, because then you start to get a little bit of clipping. If there's any haze, you can do a little bit of dehaze. I don't usually do more than a couple of clicks on that. Push the black levels up some, so that we get a cleaner, more vivid image. I just do this, I just kind of wing it and do it, by my eye. Maybe push a little bit of contrast into the image as well. And trying not to blow out any of the areas. Like this one crater here, it's kind of highly exposed, so it's kind of hard not to deal with that. But the rest of the field of view looks pretty good. You could play with exposure here, do a little bit to tweak it to your own personal liking. So I think just maybe a little bit of a bump in the exposure is good. And I'm going to click OK. Next thing would be to do is to come to the noise filter, do a slight noise reduction. primarily to do this remove JP artifact here. There's some noise that is introduced into the image during the stacking and sharpening process mostly, which is this will remove those unwanted anomalies in the image. I just do a light strength on that, and that pulls out some of the unwanted noise. You could also go back into Smart Sharpen. Some people like to use shake reduction, but to me it really destroys the image. Smart Sharpen, if you need to do it at all, I just do a light, maybe 0.3 radius on the pixel, and you can play with lens blur or Gaussian blur to see what changes it does to the image itself. It all depends on your quality of your data and how much you have stacked. You might get some different results from that. You can even reduce noise here a little bit more. I don't need to do any more noise reduction on it. It looks clean enough to me. And then lastly, I would go back to image again, adjustments, go under exposure, and now here's where you can fiddle with the gamma a little bit. If you want to push the gamma higher, if you go really high, you can see it's overexposed and clipped. If you go too low, now you start to bring out some of the surface features. You can see differences in the soil here, the minerals on the soil. That may be the purpose of your image, so that's up to you. Me, I like to try to keep it as close to what you might see looking through the eyepiece, or through any other means, or even through up close through satellite images. I don't like to add things into the image that aren't there naturally. Usually another thing I'll do is to the offset and just bump it down a couple of clicks, and that helps to get rid of some unwanted noise that might be introduced here into these dark areas of the image. And you can also play with the exposure here again if you wanted to. So right there, that in a nutshell is a very brief abbreviated version of what I do to process an image. So now what we want to do is come over here and save it, and there you go. That is how I process planetary images, basically from A to Z.
Thank you so much for watching. So I am here with Gary Varney, who just gave us that really informative talk about photographing the moon. So Gary, could you tell us, how long have you been doing this?
Well, I started visually maybe about 13, 14 years ago, but I guess probably less than maybe 8 to 10 years ago, I started to really dive into this. It's a constant learning curve. I keep my own bar, really high too, so I'm always looking to learn new tricks, new tips, and it's fun. It's a hobby for me. I'm passionate about it. It's a great escape from the chaos of today's world.
So we do have a few questions for you from our audience. The first one is from a Twitter user, Coachella Valley, who says, I film and photograph the moon all of the time, but I'm a novice. So watching this Q&A is helping me out. And they said, my camera has an autofocus that I depend too heavily on. So could you talk a little bit about autofocus and focus for photographing the moon?
Autofocus would be maybe if you're using a smartphone. Usually you would tap the screen and let it focus. If that could be toggled off, that would be suggested. The planetary cameras that I use do not have an autofocus feature. You actually focus, the telescope itself. So I would need to know what type of camera that is. But in a nutshell, yes, I would turn that feature off and do it manually, because that could be a little frustrating. As the sky changes, your camera is going to be wanting to do the focus, and do yourself a favor and turn it off.
Thank you. So Twitter user Pascal Schubert asks, what causes the blue halo around the moon?
You broke up a little. You asked me about a lunar halo.
Yes, the lunar halo, the blue lunar halo. What causes that?
Well, yeah, I guess that would be moisture or particles in the atmosphere. The moon is very intense, just like you would see a bright headlight coming at you. If there's fog or smoke or anything in the atmosphere, that's going to amplify that. I know sometimes there's I think a 22 or 32 degree halo or rainbow that sometimes will appear around the moon. That's due to ice crystals and the way it bends and reflects the light. That's really a visual treat just for naked eye viewing of the moon. So yeah, it's due to atmosphere to get those anomalies like that and those features. They're pretty cool.
And then Zach on Facebook asks, do you need a fancy camera to photograph the moon?
It's a little choppy again. Something about a fancy camera.
Yes. What I think you talked a little bit about this in your talk, but do you need a fancy camera to photograph the moon, or can you use your phone, or what kind of camera can you use?
Yeah, an iPhone will work. You can use, any kind of a digital camera with the right adaptive parts to it. But there are some very affordable planetary cameras that would be less than, say, $200 that will perform quite nominally for you. And there's a little learning curve, but it's just a USB camera. Goes into your laptop, and you, through the capture software, adjust the exposure, the gain, the contrast. It takes a little bit of getting used to, but there's really nothing fancy to it. Focus is done through the lens, not the lens, but the mirror, the optics, and the telescope. But nothing fancy about the cameras. There are some really expensive ones, but that's more for the more experienced and professional users. But they're all fun to use.
So we're wrapping up this part, but do you have any final tips or tricks for our viewers on photographing the moon? You obviously gave us a wealth of information already, or anything, any further resources you'd like to tell us about?
Don't ever give up. You will throw away more images than you save. I have many friends out there that do this. They'll contest to that. Just keep looking up. Be patient. Be diligent. Be patient. Sometimes you have to wait for holes in the clouds to come by to let you grab. I've done that many times looking at the moon or Jupiter or Saturn. You have to wait. Just have fun. Just have fun. And keep looking up in clear skies.
Excellent advice. Excellent advice. Well, Gary, thank you so much for joining us this evening, and I can't wait to see more of your spectacular images, and thank you for observing the moon with us.
Thank you. It was an honor to be here. Thank you very much.
Oh, sorry. So thank you so much to Gary Varney for joining us. I think we're going to go to a video of Claire de Lune.